Rankine cycle. To make you understand the Rankine cycle in easy way, I must bring the example of electricity. The majority of electricity we receive is coming from the steam turbine power plants, and these steam turbine power plants are working on Rankine cycle. That means the Rankine cycle is the basis of all these steam turbine power plants. Therefore, through this Rankine cycle, we will learn how the steam turbine power plants are working, what are the major organs or major components of steam turbine power plants, and how all these major organs are functioning. Hello everyone, I am Dr. Deepak and do welcome you all to my channel. So before the start, subscribe my channel to get more videos. So let's start the topic Rankine cycle. So this cycle is very important, as we know that this is the basis of all these steam turbine power plants. So in this video we'll learn the basics about the Rankine cycle, simple Rankine cycle. Then we'll learn the modified Rankine cycle, like Rankine superheat cycle, Rankine reheat cycle, and then Rankine regenerative cycle. After learning all these important topics, we'll have a the summary discussion of all these topics, and after the summary I'll try to solve the gate questions so that you can understand in better way. And finally I will leave one very tricky questions which came into gate examinations for your practice purpose. So let us start the topic. So as we know that the Rankine cycle is the very basis of all these steam turbine power plants, and to complete the Rankine cycle there are main four machine components. They are the boiler, then turbine, condenser, and pump. So if I write all these major parts, the first one will be boiler. Second, the major component is turbine. Third one is condenser. Fourth, we'll have a pump. So to understand this Rankine cycle in better way, I'll draw the schematic diagram so that you can understand how all these major parts are connected. So we'll have if this is a boiler, then it will be turbine. So this is going to be turbine, and after that there will be condenser, and then from the condenser we'll have a pump. Okay, so we can simply understand the Rankine cycle will be completed by all these four machine parts, as we have said. First one is boiler, then turbine, condenser, and pump. Okay, so in this boiler the feed water will be boiled and it will become to steam, and this steam will come to the turbine. There will be rotation of the blade inside the turbine, and from there the power will be generated, and from this turbine the steam will come to the condenser, and in this condenser the steam will be converted into the water by condensation process, and this water will be pumped by this pump machine, and this pump will put the water inside the boiler again. So in this way the whole cycle will take place. So these are the basic components by which the Rankine cycle is complete. So this is about the schematic diagram. So we can have a better understanding, the thermodynamic understanding of this Rankine cycle by drawing the TS diagram. So let us draw the TS diagram. Rankine cycle, this side it is temperature T, and that side it is, entropy, S. So first we'll start by drawing the, the saturation curve. So it will be the constant pressure line. This is constant, the boiler pressure line. This is the constant, condenser pressure line. So like this. So now we'll draw the Rankine cycle. Rankine cycle, let us take this color. So this is, the 1, 2, and this is one process, this is the 1, 2 process, this is 2 star, and here it is, the boiling process, 3, and the Rankine cycle will take place, by completing all this process. So as we are finding in this TS diagram, the 1, 2 is the pumping process, and 2 star is the sensible heating which is taking place inside the boiler. Then from the 2 star to 3, this is evaporation process. After boiling, the steam will be expanded in the turbine, so it will reach to the point 4. Again at this 4 point, it will come inside the condenser, and condensation will take place through this 4-1 process. So in this way, the Rankine cycle is complete. So simply we are getting main 4 processes here in this Rankine cycle. First one is 1, 2, which is pumping process, and from 2 to 3, 2 star 3, this is the boiling process which is taking place in the boiler, and then the steam will come inside the turbine where the reversible adiabatic expansion will take place in the 3, 4, and finally the steam will come to the condenser. It will be condensed inside the condenser, and then again it will come to the point 1. So in this way all the 4 processes are taking place so that a complete Rankine cycle is carried out. So simply we can write here, it is boiler, here it is, turbine. This is happening inside the, condenser, and this is, the pump. So all these 4 processes are taking place in all these 4 major organs: boiler, turbine, condenser, and pump. So in this way we get the Rankine cycle. Okay, so in this Rankine cycle we can understand there are 4 major machine components: boiler, turbine, condenser, and pump. So this is all about our Rankine cycle. Okay, now we can learn more about the Rankine cycle when we compare this Rankine cycle with the Carnot vapor cycle. Okay, so let us draw the Carnot cycle so that we can have a comparison between this Rankine cycle and the Carnot cycle. So as we know that Carnot cycle is this side, it is TS diagram. So this is a constant pressure line, this is constant pressure line in condenser. So in case of Carnot cycle, this is for the case of Carnot cycle. So as we know that Carnot cycle is very the ideal cycle from where we have the fundamentals of Rankine cycle and other important cycles. So in this Carnot cycle we get 4 processes. So this is 1, this is 2, this is 3, this is 4. So in case of Carnot cycle we have 4 processes. So in the Carnot cycle we get this one process 1, 2, this is the reversible compression process. And 2 3, you can see that in the TS diagram here constant temperature is happened. That means this is a constant temperature process. This is isothermal process. Isothermal process. Isothermal process. Again 4-1 is isothermal process, because here temperature is remaining constant. So this is also isothermal process. Isothermal process. And this 3-4 is which is happening in the turbine. So that is reversible adiabatic process. Adiabatic process. Again this 1-2 is also adiabatic process. Adiabatic process. So simply we can get 4 main processes in a Carnot cycle. First one is the reversible adiabatic process. Here it is isothermal process, and then adiabatic reversible adiabatic process will take place, then isothermal process. So in this cycle we get the 4 processes, but practically this Carnot cycle is not possible. That's why slight modifications are made in case of Rankine cycle. So I have drawn here the Carnot cycle so that you can have a better idea on the Rankine cycle. You can find the very important differences between Rankine cycle and Carnot cycle. So let us move to earlier slide so that we can have a comparison between this one Rankine cycle and Carnot cycle. So as we said, this is Rankine cycle. Rankine cycle. Okay, so simply we can find out the differences between Rankine cycle and the Carnot cycle. So since practically this Carnot cycle is not possible, some modifications are made in case of Rankine cycle. So in case of Rankine cycle, what happens? This isothermal process is replaced by boiling process where sensible heating and evaporations are taking place at constant pressure process. Okay, temperature will not remain same in case of Rankine cycle. Then we have a reversible adiabatic process which is same as the Rankine cycle. Then this isothermal process is replaced by the constant pressure condensation process. And finally we have a this adiabatic process. So these are the modifications where we have a constant pressure boiling process, then we have a turbine reversible adiabatic process, then condensation, and here it is reversible adiabatic which is taking place in pump. So these are the very important differences between Rankine cycle and Carnot cycle. So here I have tried to make you understand how the Rankine cycle and Carnot cycle are different. So I hope that you have understood the basics of Rankine cycle and how Rankine cycle is modified version of Carnot vapor cycle. Okay, so we have learned the schematic diagram, how the Rankine cycle is carried out by using all these important machine parts. Then we have learned the TS diagram. Through this TS diagram we have learned how the processes are taking place so that we have a Rankine cycle. And after learning the Carnot cycle, we have understood what are the modifications made inside the Rankine cycle so that we can have a the practical vapor power cycle which can be applied in case of steam turbine power plant. So now we will study the modified Rankine cycle, where the simple Rankine cycle has been modified to get the better performance. So now we'll have first one Rankine superheat cycle. Next we'll study the Rankine reheat cycle. After that, we will study the Rankine regenerative cycle. So we'll study, three different modified Rankine cycle. So here you will see the TS diagrams of all the three, modified Rankine cycle. This TS diagram is showing the, Rankine superheat cycle, and this cycle is showing, the Rankine reheat cycle. And this is the TS diagram of regenerative cycle. So using these diagrams, we'll compare how superheat cycle and reheat cycle and regenerative cycle are different. So to make it easier, okay, I have drawn the figure of simple Rankine cycle, okay, to show that we can easily compare the superheat cycle, reheat cycle and regenerative cycle with the basic simple Rankine cycle, so that in easy way we can relate, we can compare all these Rankine cycles. So as we know that simple Rankine cycle, it is completed by four machines of steam turbine power plant. First it is boiler. So in the boiler it is steam, the water is converted into the steam, then the steam will come to the turbine. In the turbine the steam will be expanded. So from the turbine that steam will come inside the condenser where condensation will take place. That means the steam will be converted into the water. So this water will be pumped. After pumping, this water will again reach boiler. So again it will be converted into the steam. So in this way, the simple Rankine cycle is continuously taking place. So using boiler, turbine, condenser and pump, the whole process of simple Rankine cycle is taking place constantly. So now we'll see how this superheat cycle has been modified. The major aim, the objective of all these three cycles is to get the higher efficiency. So higher efficiency will be obtained by using these three cycles. So now we'll understand how the modifications in all these cycles are giving the higher efficiency. So let us first consider the superheat cycle. Okay. So in this superheat cycle, we will see the steam has been superheated up to 3. So earlier it was the point 3 up to the saturation point, up to the superheated point 3. So now in this superheat cycle, this point has been reached the point 3. So you can easily see that steam has been superheated. Okay. Earlier the steam was at the point 3. This is saturated point. Now in the superheat cycle we can see that the steam is superheated at the point number 3. Okay. And after superheating, it will come to the turbine and it will be expanded. Again it will reach the condenser. So in this way, the superheat cycle has been done. So simple modification here is that the point 3 where steam is saturated, this steam is here at a superheat condition. Okay, so after getting its superheat condition, it will come to the turbine. So in this way, we have a the steam which is having less content of moisture. So this is the advantage of this superheat cycle. So from this TS diagram, we can see the area under the curve. So this area under the curve is representing W net. So net work done. So here we have got work done addition, and again we'll have a higher heat addition and heat rejection. Ultimately the W net is higher. So where we get that efficiency is, we know that efficiency is W net by QH. Okay, so we can find out the efficiency by dividing the net work done by the heat addition. Okay, so here from the TS diagram we can see the area under the curve for the work done is higher. So obviously in this superheat cycle we have this higher work done, and we have QH. So this is this amount is bigger than this value. The W net is higher than the QH, the amount of change. Therefore obviously in this superheat cycle we get the higher efficiency than the efficiency of simple Rankine cycle. Okay, so here we have understood how this superheat cycle has been modified, how it has given the higher efficiency than the simple Rankine cycle. Now we'll move to the second modified Rankine cycle, which is called Rankine reheat cycle. So here you see in this reheat cycle some modifications are there. 4 we have 1 2 star 3 4. Again from 4 to it will come to the 5 and then 6. So in this reheat process what happens, 2 turbines are applied. So this turbine is higher stage, the pressure is at higher stage, and this turbine is having at a lower pressure stage. Okay, our simple Rankine cycle will become 1 2 2 star 3 4 5 and 6. Okay, so how it happens here, up to 3 the process remaining almost same to the simple Rankine cycle or superheat cycle. So after expansion in the first turbine, that steam will come to the boiler. So here one reheat system will be added. Reheat process, the steam will be reheated, its temperature will be increased up to 5, and again it will come to the next turbine, and then condensation will take place. So in this reheat cycle the difference is that instead of 1 turbine 2 turbines are applied. So in this way we get the better work done here. So obviously in this process we can find out a better efficiency. Okay, so by applying this reheat cycle where instead of 1 turbine 2 turbines are used, we get a better work done. So as a result we have a better higher efficiency. Okay, I hope that after this the concept of superheat cycle and reheat cycle are clear. Now we'll move to our last modified Rankine cycle, which is called regenerative cycle. So to make you understand the regenerative Rankine cycle more easily, I have drawn both the simple Rankine cycle and regenerative Rankine cycle. For easy understanding, I have drawn TS diagram for both the simple Rankine cycle and for regenerative Rankine cycle. And these are the two schematic diagram for simple Rankine cycle and for regenerative Rankine cycle. So by studying all this figure, we can easily understand how regenerative Rankine cycle is different from the simple Rankine cycle, and how the modification made in the regenerative cycle has been the reason to increase the higher efficiency. So we know that efficiency of simple Rankine cycle is increased by using the regenerative Rankine cycle. So to understand in better way, let me discuss. This is a TS diagram of simple Rankine cycle. So we can understand that point 1, 2, 2 star, 3 and 4, again 4, 1. This is the cycle which is called simple Rankine cycle. Here we can see certain modifications in this cycle. Here 1, 2. So 1, 2, 2 star, 3, 3 star and 4, again 1 is the cycle which is called a regenerative Rankine cycle. Okay. So simple difference is that 3 star and 4. In the simple Rankine cycle, it is 3, 4, 3, 4. Okay. Here it is 3 star and 4. So up to the condition of point 3, this regenerative Rankine cycle is similar to the simple Rankine cycle. After point 3, that is the turbine. Okay, inside the turbine, some modification has been made here. That's why our TS diagram become 1, 2 star, 3 star and 4. Okay. Okay. So here the purpose of the purpose of getting this regenerative cycle is that we have a Q regenerative. Okay. So this is the amount of regenerative heat. Okay. So in this TS diagram, we can find out that this Q heat generated is rejected by the turbine. Okay. And this heat is gained by the water. Okay. So how does it happen? Follow the schematic diagram. In the simple Rankine cycle, we have pump. The pump will draw the water from condenser, then it will push the water inside the boiler. Okay. So in the boiler, the water will be heated, it will be boiled, it will be evaporated, then it will come to the turbine. Again from the turbine, it will come to the condenser. So in the condenser, the steam will be converted into the water. Again it will come pump and boiler, etc. In this way, the whole cycle of simple Rankine cycle take place. But here you see the modifications. You see the modification. Here you see the water which is coming from the condenser. So here the water coming from the pump, it is going to the turbine. So inside the turbine, heat exchange will take place. So heat exchange between the water and the hot steam which is existing in the turbine will take place. So due to the heat exchange, the temperature of water will rise, and then the heated water will go to the boiler. So after that, again the whole process will take place as per the simple Rankine cycle. So here the difference is that this water feed water after the pumping. So here in case of simple Rankine cycle, we find the water from the pump, it directly goes to the boiler. But in this case, the water after pumping, it will not go directly to the boiler. This water will come to the turbine. Okay, after turbine, it will reach boiler. So here the regeneration happens. Okay, so in this turbine, regeneration happen. Okay, so regenerative heat exchange takes place. So the water which is coming from the pump, okay, it will come to the turbine, where heat through the heat exchanger, heat exchange will take place between the water and between the hot steam inside the turbine. So in this way, the water will be heated, and this heated water will come to the boiler. Okay, so inside the boiler, whatever water will come, it will have a higher temperature. In this way, a regenerative heat is collected from the turbine. Okay, so same phenomena, same principle we can explain using the TS diagram. Here you see the regenerative heat which is lost inside the turbine. It is added in the water. Okay, so water is getting the heat from the steam, and after heated, this water will come to the boiler here. So here further evaporation will take place, and then the process same as will happen, okay, in case of simple Rankine cycle. Clear? So here the difference in a regenerative Rankine cycle is that instead of directly going to the boiler, the feed water from pump will come to the turbine, it will be heated, then it will move to the boiler. Only at this point the difference is there. Okay, so due to these simple modifications, the regenerative process take place, and we had a heat gain in the water, and we'll have a heat loss from the steam. So in this way, the advantage of heat exchange is made in case of regenerative Rankine cycle. Okay, so now you will see that this regenerative heat will be the reason of higher efficiency. Okay, that means the efficiency will be increased due to this heat gain, due to the regenerative process. Okay, so here further you can understand, here the heat addition, it will come from the heat rejection from the turbine. Okay, so if you ignore all this, heat exchange here, our final cycle become this process 1 dash 2 star 3 and 4 dash. Okay, so this is becoming the Carnot cycle. Clear? Okay, so by considering all these processes, the schematic diagram, we find out the final cycle. If we ignore the heat exchange, the final cycle will be equivalent to the 1 dash 2 star 3 and 4 dash 1. So this cycle is nothing but Carnot cycle. That's why we can see that the thermal efficiency of regenerative Rankine cycle is equal to the thermal efficiency of Carnot cycle. Okay, so now we can realize how interestingly this regenerative Rankine cycle is carried out, so that our Rankine cycle can be equivalent to the Carnot cycle. Clear? So from this diagram we can easily find out this final cycle becomes equivalent to the Carnot cycle. In this way we have a better efficiency, we have a efficiency which is equivalent to the efficiency of Carnot cycle. Okay, so in this way we get the advantage of this regenerative Rankine cycle. I hope that you have understood here the regenerative Rankine cycle, and you have also understood how this cycle is compared with the simple Rankine cycle, and how the efficiency has been increased. Okay, so this is the end, almost end of the class. So I hope that you have understood the simple Rankine cycle, the principle behind this particular Rankine cycle, how it is connected to the steam turbine power plant, because the majority of electricity we receive is coming from the steam turbine power plant, and these steam turbine power plants are working on the basis of this Rankine cycle. Clear? So after studying the simple Rankine cycle, we have studied different modified Rankine cycle. I hope you have understood. Now time for solving the gate questions. Okay, so now I'll take one gate question which came in the year of 1994. So I'll just explain that particular questions and I'll give you the answer. So now I'll read out the question of a gate examination which came in the year of 1994. For a given set of operating pressure limits of a Rankine cycle, the highest efficiency occurs for option 1 saturated cycle, superheated cycle, a regenerative cycle, and option 4 reheat cycle. So through this question it is asked, okay, to compare the all given cycles: saturated cycle, superheated cycle, regenerative cycle, and reheat cycle. Given the condition of pressure limit, the pressure limit is same for all the cycle. Okay, so here the answer will be the regenerative cycle, because when as per our discussion, when the two pressure limit are kept constant, okay, when the boiler pressure and condensing pressure are same for all the cycle, okay, we can understand the regenerative Rankine cycle gives the highest efficiency, okay, because we have studied this regenerative Rankine cycle is giving the cycle which is equivalent to Carnot cycle. So as we know that Carnot cycle gives the highest efficiency in case of reversible cycle. So automatically out of these 4 portions given in the questions of gate examination, we can find out for the same pressure limit the regenerative Rankine cycle will give the highest efficiency. Okay, I hope that you have understood the answer of these questions. You are able to make the relation between the Rankine cycle and the question given in the gate questions. Now I will move to another step where I will leave question for you which one is very tricky and came in a gate examination in 1995. So the question which gave in gate 1995 is: consider a Rankine cycle with superheat. If the maximum pressure in the cycle is increased without changing the maximum temperature and the minimum pressure, the dryness fraction of steam after the isentropic expansion will decrease or increase. Okay, so this question which came in the gate examination of 1995, I am giving to you for your practice purpose. I hope that you can solve this problem given in the questions. I believe that you can also answer similar kinds of problems which are very tricky. So with this I will complete my class. I hope that you have enjoyed, you have learned lots of things on the topic today. Thank you so much. See you in the next class. To support me, subscribe my channel.